Okay, so in this video I'm going to be doing integration by substitution, and integration by substitution is the same as chain rule run backwards. So it's a good idea to go back and review my videos on chain rule, and that will help you get ahead. But I'm going to give you a brief introduction to chain rule as well. So what we've got, so here's our problem that we're going to use for chain rule. And so we have a function inside a function. So I could put that as parentheses. So I've got x squared plus 3x plus 12 is my function that is inside of the function e to the blah. So that's my blah in the e to the blah. So what I'm going to do for chain rule is I'm going to say y equals e to the u, and u equals x squared plus 3x plus 12. And then I'm going to say dy du is equal to the derivative of that, which is just e to the u. And du dx is going to be 2x plus 3. And so then I'm going to say that dy dx is du dx times dy du. So I'm going to get 2x plus 3 times e to the u, and e to the u is e to the x squared plus 3x plus 12. So that is the derivative of that. Well, then it stands to reason that the antiderivative of this must be that. So then we're going to just go and we're just introducing, so it's just going to be an obvious example, but I just want to show you how it works. We're going to take the integral of 2x plus 3 times e to the x squared plus 3x plus 12 dx. Now we already know the answer to that. That's not a mystery, but we're going to show you how to get there. Okay, so what I'm going to do is, the first thing I'm going to do is I'm going to say that u equals x squared plus 3x plus 12. And then I'm going to say that du is equal to, I'm going to say du dx is equal to 2x plus 3. And then I'm going to switch that around, so I'm going to say dx is equal to 2x plus, du divided by 2x plus 3. And now we're doing integration by substitution. So now I'm going to substitute. I'm going to leave this 2x plus 3 out here. Then here, instead of writing e to the x squared plus 3x plus 12, I've replaced that with u. So I'm going to put e to the u. And then dx is going to be replaced by du over 2x plus 3. And now you see what happens. The 2x plus 3's cancel out, and so I'm left with the integral of e to the u du, which I know that's just e to the u plus c. And then I also know that u is e to the x squared plus 3x plus 12, and then I have this plus c, because there's always an unknown constant. So there's chain rule, and then we just run it backwards. And so then I want to give you one other example in this video, and then I've got 3 other videos besides this one lined up for integration by substitution. Okay, so what we're going to do is we're going to go sine cubed x cosine x dx. And then what I want to do, because I'm just introducing it, is I want to rewrite that And so this shows more clearly that this is my function inside of a function. So I've got a function inside of a function. So I'm going to say u equals sine x. That's my inside function. Then du dx is going to be equal to the derivative of sine x, which is conveniently enough cosine x, which you see right out there. And then I'm going to say dx is equal to du divided by cosine x. And so now I'm going to say I have the integral of u cubed cosine x du divided by cosine x. Once again, conveniently enough, the cosine x's cancel out. So I've got the integral of u cubed du, which we know 1/4 u to the 4th plus c. And so my answer is going to be 1/4 sine to the 4th of x plus c. And that's my answer. Now the last thing that I want to say about this is that you're looking for integrals where one part is the derivative of another part. So integration by substitution really relies on one part of the integral being the derivative of another part. So in this case, 2x plus 3 is equal to x squared is the derivative of x squared plus 3x plus 12. And in this case, cosine x is the derivative of sine x. Okay, that's that for that video, and we'll move on to a few more examples in 3 more videos.